Welcome back. Today we're talking about open sourcing of the Golioth reference design template and reference designs in general. I have Mike with me here who's going to talk about some of the reference designs we've been working on.
Hey Chris, good to see you again. I got to say, it feels pretty good after the last like 9-ish months of working on this. We have been sharing it with customers, but now to have it actually publicly available as we hit our first 1.0.0 release, I'm excited to talk about it.
Yeah. So like Mike mentioned, we have projects.goliath.io is where we store all the information about the different reference designs that we're working on. We show you how to build different application specific things in different verticals. So if you wanted to build something for an asset tracker or ag tech or trash can monitoring, all of these different things that we've been talking about, we've been recording about, they're all available here. And now we're going to take a look at some of the guts in the firmware underneath the hood in the firmware. So Mike, what was the genesis of all this? Like, how did it start before we had this template?
Right. So basically, if you were making an IoT device and you want to use Golioth, you need something running a real-time operating system with a network stack that can talk to Golioth. And for the majority of cases with us, that's Zephyr real-time operating system. For many of our customers looking for cellular applications, and Nordic's NRF9160 cellular modem works wonderfully both with Golioth and uses Zephyr as the development environment. And so everyone had to start there and kind of like stack up all of their dependencies and all of their features on top of each other. And we thought we should be able to make this a little bit easier so that that same part that people are building in the firmware doesn't have to be built separately by every single person, but it's still kind of generalized enough that no matter what your need is, you're not like removing a bunch of code. And so we have the ability to stand up an encrypted connection through the cellular network to send some log messages, some time series streaming data, to get some state data stored to the cloud, to monitor the device settings for your entire fleet, and issue remote procedure calls. And of course, the one that's in all of our reference designs and all of our different code stacks are over-the-air firmware updates. And so this template does that all the first minute that you get it running on your device.
Yeah, we should say we're standing on the shoulders of giants here because all of the stuff that we're talking about here with the reference design template and really even the reference design itself. So we're going to talk about the DC power monitor is built in the template. The template is built on top of the Golioth Zephyr SDK, which then operates on top of Zephyr, which then talks down to your hardware and everything else that's in there. There's all the cloud stuff as well that we offer as a service. That's what Golioth as a company does. But we should say that each of these things, there are capabilities to see each piece out there. For example, you can go into the Golioth SDK and see just our sample on how to do logging. But seeing that then alongside all the other things we do, that's more something that you do in a product that you might want to see in a reference design or in the template, as it were.
Yeah, absolutely. And for me, one of the best parts of that stack up that you just talked about is that Nordic's testing all of their stuff, Zephyr's testing all of their stuff, Golioth's SDK is being constantly tested. And then when we pull in these SDK changes to the template, we test that as well. So there's a ton of proof points along the way that things are going to work the way that they are expected to. So if you start building your app from this, you kind of benefit from that entire testing chain.
Yeah, we kind of see ourselves as we're the guinea pigs that many, we're testing it as though Mike and I are a product firm using Golioth stuff, and then you can build on top of the stuff that we're doing. So let's take a look at what Mike's been is going to showcase here. Mike, can we look at your screen?
Yeah, let's just jump in. So this is the open source repository right here called Reference Design Template. And if you're just starting out, go ahead and read the README. You will notice that we do have releases here. And so if you're looking to purchase a dev board, the releases available do have binaries inside of them. So here's binaries for the NRF9160 DK. The full binary is for flashing to a brand new device. The update binary is for over-the-air updates. So that's why there's two there. But of course, you can build these yourself. There are instructions in the README on how to clone this template into your build system and how to build it for your device and flash it to your device. But I think probably going through and looking at the code is a good way to start. And so all of the kind of interesting parts are in the SRC folder, starting with the main. And when you drop into main, If you're familiar with the way the Goliath system works, a lot of the things that you would expect to find here are already here. Like, for instance, here's a function that runs when Goliath is first connected. You'll find things like if you have LEDs on your board, you can turn the LED on when the connection first starts. But jumping down, we have the actually LTE link handler. If you've never worked with the LTE before, it's nice to have this already worked out for you. And you're going to get a lot of different messages for this. So you're going to get a message like, oh, you're on a roaming network, or you're on a network, but you only have access to emergency data. So that's sometimes good troubleshooting there. Most of the time, you're going to see messages like searching or messages like connected right here. We also do a bunch of kind of helper things in here that are good practices. Like this one is going to go ahead and print out the actual modem firmware version from Nordic every time you boot up.
Super important.
Yeah, I actually was working last week and I was having a problem and realized I was using modem firmware from 2020, and it's because I was working on something that wasn't using this feature right here.
Exactly.
And surprise, updating the modem firmware from 3 years ago.
And it's going to actually log it to Goliath as well, right? You see the log info, which will also then get passed along to the Goliath logging subsystem, which then will show up on the cloud. So then you can see that. So if you happen to have an old device that hasn't had its firmware updated, you'll have passed all the way down the line as well.
Yeah, that's right. So all of these logging messages, so here's a log debug, here's a log inf, these are all set up with our Goliath backend logging. So these are going to show up on the cloud as well. This is another nice one. So this is the actual reference design firmware version. I would highly recommend always printing this one out at boot because you can easily troubleshoot for stuff like that. Moving on into it, just very common things like, for instance, initializing all of the different services, and we'll jump into that in just a minute. But so we have everything broken out by Goliath services. So stateful data, the app work is really like all of your sensors. DFU is the device firmware update, so that's the over-the-air updates that we talked about before, the system settings, and the remote procedure calls. We've broken those out so that before we kind of get going with all the network stuff, you can make sure those are set up. And then we do a little bit of handling here for the network and set up some buttons. So there are some user buttons on these boards, and we show how to use that before we actually jump down.
That's one that I actually find is super important too. If you're demoing, say you're demoing for your boss, and like you have a timer built in where it's like going to fire a sensor reading every 10 minutes. You don't want to be like, well, no, wait 9.5 more minutes, boss. I'll show you the sensor reading. You want to be able to like trigger a reading every single time manually. And so you can do that on the DK or other hardware. So
yeah, and I won't go in full into that, but I mean, the core of the program is right here, this really simple loop. And so what it's doing is it's saying, go and do the sensor work right here, and then sleep for this amount of time. This amount of time is settable, but all the button does is it wakes this thread up from sleeping and it goes back up to the next thing. So it's kind of a simple way of approaching it, but very useful. But if we actually jump over into the app work here, we go, I think it's down on the very bottom. I mentioned the initializations. Not much is happening here. We're just making sure like that we know what Goliath client is being used. And in this case, they're all using the same Goliath client, but to keep things for the future, in case you ever wanted to, for some reason, run multiple Goliath clients, you could. But if you had particular sensor setup stuff that you needed to do, like you wanted to set, I don't know, some type of calibration values or get a couple of readings and throw them away or something, you could easily add that to here. And then once we get to the loop, all of the work is going to be done right here. And in this case, I have a battery monitor built in because some of the boards that we use have a battery on them. It's set so that if you don't tell it to use it, it won't get in the way, but it's there as maybe a reference for your own design. You can adapt that to whatever's reading the battery on your device. I send a little log message, and then we set a counter value, and we just format that counter in a few different ways. So this is kind of a stand-in for the sensor. You would do your sensor reading right here, and then send it to Goliath. We're actually using the Goliath stream push right here. And so this API is saying, send this to Goliath and make sure that Goliath uses a timestamp so that we're collecting like temperature data every minute or 5 minutes or 10 minutes. You want to have a timestamp sent to that. It's just as easy as that after having formatted it in the JSON format right here. But of course, you have the option of formatting it as CBOR as well. There's a little bit more printing out stuff. So we have a faceplate that we call Ostentus here. Again, this if enable is just saying like, if you have this piece of hardware, why don't you also go ahead and update stuff here, but it's completely optional.
Yeah. So one thing, so if people have seen on our project stack.io page, you'll see this kind of this form factor. Like Mike said, we have a sensor faceplate and stuff like that. We don't expect that anyone would have that because you'd have to build it yourself right now, and we don't think that is the case. But all of this stuff is designed to work with the NRF 9160 DK as well, and we'll have more details about that on the projects page for each individual one. This is for the we're looking at the template currently though.
Yeah, and so I think, some other things that we like to look at, if you have state data that you want to keep track of, like the device wakes up and wants to know what its last reported state was, so it can kind of start off with that. That's this app state file that's in here. And again, there's an initialization command right here. And in this case, I have set up a semaphore to block until to make sure that the initialization runs, because you want to make sure that everything is set up before you run anything else. So it's going to check and make sure, like, oh, should I be updating stuff? Have I actually been initialized? But other than that, we do some things like this is a callback from Golioth where it's actually going to be observing some data. And I'm guessing yeah, there's an observation function right here. And this is just boilerplate right from the Golioth examples, but it sets up an observation here where it says, all right, go and look for this endpoint right here. And I think I can do actually I don't have it set up on this computer. Let's see, state desired. Where did I set that up? It might be in my header file right here. All right, so I've actually just set up some defines here. And so I'm gonna go ahead and observe a desired endpoint. And so if I look at the Golioth back end here, you can see I have this desired value. And if I was gonna change one of these to a number, the device would see that, and then it would automatically report its state back to whatever that value was. So if I change this to 42, it would get reported right back here. So that's what the app state does. It handles all that. It listens to Golioth, it updates on the state, so you can see what state was my device at the last time that it reported in. If the device loses power and boots again, it can look up its own state and restore it. It's just kind of nice that way.
As it mentions a little bit further up there, that's kind of like a digital twin concept as well. It's kind of a lightweight digital twin. So if you're looking for that sort of thing, that's a way to get that.
And that's one of the things that we recommend a lot is like the in this pattern, this desired state right here, both the cloud and the device can write to this. The cloud would write what it wants the device to do. And then I have the device change these to -1 to indicate that it processed them already. But only the device should be able to write to this state endpoint so that you know, like, hey, what was my device doing last time it was in a known working condition? The other one that I really like having on all of our devices, of course, over-the-air update is just like standard stock, but then I also like to have settings on there. And in this case, our loop delay settings right here, it's set to 20 seconds, but you can change that for your whole fleet or by devices. There's a folder in here that goes through how all of that is set up. So there should be an initialization in here somewhere. There we go. All right, so our initialization does the actual registration with Golioth right here. And then it also does an observe setting. So it's going to say, all right, go ahead and observe that for changes. So it sets up both the name of the callback that you're going to go and look at. And here's the Golioth settings register callback. So it's going to say when you get an on setting callback, then you want to run that on setting right here. All right, so we run through all of this. We're going to get our loop value back from Golioth. We're going to do some parameterization to say, like, is it a valid amount of time that we're setting it for? And then it's going to set our delays. And that, again, is the delay that was being used at the bottom of main.c. That's where that value comes right here. So I can go in here and change this to, let's do our sensor read every 5 minutes, and it's only going to wake that loop every 5 minutes. And the other thing that I really like to see in all of these, like I said, is the device firmware update. And these files, you don't really need to do anything in these files. These are already set up for you. And so I generally don't change anything in here. This sets up its own thread because over-the-air update is such an important thing. And so when you see this run, your sensor values are still going to be harvested, or still going to be sent to Goliath. This thread's happy to run all by itself. So if you have a large binary that's going to take what would normally be like 3 or 4 sensor readings in order for it to download the whole thing, those sensor readings will still happen. It will then verify what it downloaded, reboot, verify that it's working correctly and it has the right version, and go about its merry way again. So it kind of minimizes the amount of downtime you have due to over-the-air updates.
Yeah, I'd say as a user, so I'm an end user of the template because Mike, authored the template and I get to modify it. I would say in order of what I use, I say work, then settings, then RPC, and then state. That's probably the most commonly changed things in that order. But if you're changing anything, you're probably, especially when you're demoing it and trying something out, you're probably interfacing with a sensor either over I2C reads or using a Zephyr sensor, putting that into a CBOR string, and then sending that out to the cloud using the stuff using the example inside the app work.
Yeah, I mean, you definitely use over-the-air update. You just don't need to
That's
change
right.
anything.
I use it all the time. I just don't have to. I don't have to touch it. So, but like in the order of when I'm usually changing things in the project, it's the app work.
So with this same template, we produced a bunch of our reference designs. Like the DC power monitor is what we're looking at right here, and you can see these are the different versions of the firmware that I've released and actually pushed up to the device. And you can see I've tagged the device with DC power monitor. So all of that code that we were just looking at just uses this automatically. It doesn't really care what version or what tag number, like all that stuff gets taken care of for you, which I think is really nice. The other one that I use frequently is the RPCs. The thing that I use the most for RPC, I don't know, actually, I use all of them quite a bit, but built into this is a network info, which is kind of nice. So you can get on there and see a whole bunch of different network data for the cellular network. So you can see like what service you're on, what area you're on, what the band is, what the power is. There's, I don't know, a dozen different things that go in there. We have another one that just reboots the device. So if for some reason something's not looking good, and especially if you don't have physical access to the device, it's really nice to be able to just send the word reboot. And I mean, that's as easy as choosing which device it is. So if I have a DC power monitor, I can go to a remote procedure call and issue the reboot command. I would click this button. Right now the device is not running, so it's going to have a timeout if I try to run that.
So some of the things you're mentioning here, these are built-ins that is part of the template. So the network info, the reboot, the log set levels, those all kind of come with the template. And then you can write your own custom ones. So if people watch the Thingy 91 video, Mike and I created the thing that plays little songs on a buzzer speaker, right? So like then you can also pass things through RPCs from the cloud down to the device.
Right. And if you just walk through this code, so the initialization right here calls an app RPC register. And in that RPC register, you can see what we're doing here. So there's a Golioth registration for that. We tell it like, okay, if you get the word reboot in here, so here's the reboot one, here's a set log level right here. Here's again, network. But if you get the word reboot, then go and run this on reboot message right here. And so I look for on reboot, here's my on reboot callback that's going to be fired automatically. And I've just called this one is, I guess, a little bit different. I actually submitted to a work queue because I want it to do a nice little countdown before it actually gets to the reboot. But it's running like a one-line Zephyr command, which is telling it to do the actual reboot. So it works out pretty easily. And I think it's not too hard to follow through the function calls in the reference design template. That's really the goal that we set up here, is this code is readable and you can learn from it.
Yes, definitely. On that topic, we would love your feedback. We'd love your thoughts, your issues, anything like that. We'd love to hear from you, especially if you're using these and building out your own devices. Mike and I will continue to be doggy fooding our own work here in terms of building out additional reference designs. We also have other team members who are doing the same. And but as people out in the world that are trying this out, you might want to just go and look at it if you're kind of a newer Zephyr user and seeing how we structure programs. But you also might want to just take that template, fork it, and be off to the races building your own application. And if you do that, we want to help you to do so. As a reminder, all first 50 devices on your Golioth account are free, so we don't want that to be a blocker for you. And yeah, we think the template and going open source with these will help to help people build more things that are out in the world and IoT connected.
Yeah, so keep an eye on projects.goliath.io. We already have the DC power monitor that is public. We have a couple more that are in review right now, and we think 1 or 2 a week until all of them are available. So check back often.
All right. Well, thanks so much, Mike. And we're looking forward to more reference designs coming out soon.
See you then.